A few more trends that we should mention. Reactivity. We're going to look at this one in class and in the lab. The atoms get more reactive going down a group. And again, this all kind of relates to the size and the attraction between the nucleus and the electrons. Chemical reactivity involves a change in electron structure, whether you're gaining electrons or losing electrons. Well, going down a group, the atoms get bigger. The attraction is weaker between the nucleus and the electrons, so it's really easy for these big atoms to lose electrons. They have very low ionization energies. That makes them highly reactive. A change in electron structure is a chemical reaction. The guys at the bottom of the periodic table will easily give away electrons. So we'll test a couple groups in class and in the lab. And as we go down a group, let's say lithium, sodium, potassium, rubidium, they should get more reactive. Now, the trend going across is okay. In general, reactivity decreases going across a period. I mean, eventually when you get across the period, you hit the noble gases, and they're completely non-reactive. This trend works really well for the metals. Like group 1, the alkali metals are the most reactive metals. You throw them in water, they go crazy. Group 2, the alkaline earths, are still somewhat reactive. They'll still react with water, but not very violently. Then you go through the transition metals, and these guys become pretty stable. I guess the one group that kind of shoots this trend is the halogens. Except for the halogens. The halogens are still highly reactive. Highly reactive nonmetals. Because again, if you think about it, a chemical reaction involves any change in electron structure, whether you gain electrons or lose electrons. Metals are more likely to lose electrons, but as you go across and you hit the nonmetals, they're more likely to gain electrons. Again, we want to fill our orbitals, and so as you go toward the end of a period, you've got almost full orbitals. The p orbital might have 4 electrons, 5 electrons. We really want to fill them with 6. And as we go across, the electronegativity increases. So we said like these halogens are highly reactive because they really want to gain one more electron. So the halogens might be kind of an exception. In general, sure, going across, the atoms tend to get a little less reactive, except for the halogens. They are highly reactive. A few other small trends. There is a trend in valence electrons going across the periodic table. Everybody in group 1, all the alkali metals, have one valence electron. Their configurations will all end something S1. 1s1, hydrogen. 2s1, lithium. 3s1, sodium. And so on. They'll have very similar electron structures, with one electron in the outermost s orbital. All the alkaline earth metals have 2 valence electrons. Their configurations will end S2. But now we skip the transition metals. They don't follow trends very well. The number of valence electrons can change. But we can pick it up again in the boron family. Everybody in the boron family has 3 valence electrons. Their configurations are all something S2, something P1. So for example, boron is 2s2, 2p1. Aluminum, 3s2, 3p1. But they'd all have a total of 3 electrons in their highest energy level. Then you go to the carbon family, everyone has 4. The nitrogen family has 5, the oxygen has 6, the halogens have 7, and most of the noble gases have 8, except for helium. Helium really only has 2 valence electrons, because he's only filling the one s orbital. And it makes sense, because each time you go across, you're just adding another electron. So by the time you hit the noble gases, they'll all be S2P6, for a total of 8 electrons in their highest energy level. So now what we might do is like put these trends together as little clues and try to identify an element. So we could say, what is the most reactive element with 2 valence electrons? Oh, okay. 2 valence electrons, that's group 2, the alkaline earth metals. The most reactive would be at the bottom of the group. Oh, radium. So if you know the trend in valence electrons, it'll help you identify a group. Other little things we should mention. Diatomic elements. Diatomic, I think we used that word earlier in the year. Diatomic means 2 atoms. These are elements that exist in pairs, 2 atoms chemically joined together. The diatomics are hydrogen, nitrogen, oxygen, and all the halogens. Fluorine, chlorine, bromine, iodine, and if we had it, which we don't have any, but technically astatine is diatomic. They kind of follow a little pattern on your periodic table. So you have hydrogen in the upper corner, but then the rest of them kind of make the number 7. Fluorine, chlorine, bromine, iodine, astatine. So 7 of them kind of make the number 7. And then you got hydrogen up in the corner. A lot of them are gases. Hydrogen, nitrogen, oxygen, and then all the halogens. When we get into the bonding unit, then we'll see why. There is a reason why these atoms are so stable when they come in pairs. But for now, it might, again, identify an element. So they might say, this is a diatomic element with 6 valence electrons. And we'd say, oh, that's like oxygen. Other little things that we could mention. I had some of these on here. I'll write it nicely. In general, solids are at the bottom. Liquids would be in the middle. And then the gases are typically found on the top of a group. So we'd have gases on the top. And we'd have solids on the bottom. So for example, like with the halogens, fluorine and chlorine are gases. Bromine is a liquid. Iodine and astatine are solids. In general, density increases down a group. Which kind of relates back to the fact that the solids are usually at the bottom of the group. As the masses get bigger, the density usually increases going down a group as well. So what we'll do then is use some of these trends to help predict properties. We'll use them to predict chemical reactions, compatibility. Will these atoms want to bond? Will these atoms want to react with each other? It's good stuff. So these terms will come up at other points throughout the year.